In order to understand the last section of the normal distribution chapter, we're going to have to understand what's called the distribution of the sample mean. So let's look at a specific example to introduce this topic. Let's say we've got a random variable x, and x is the salary of a random person in London. And let's say that we know that the x is distributed normally with mean 50. So on average, we'd expect someone's salary to be 50 in London, and variance 100. So standard deviation 10. Now, let's say that we want to go and sample n people. So by that I mean I go out and I ask n people's salaries. And let's say that our sample is x1, so x1 is the salary of the first person, x2 is the salary of the second person, etc., all the way up to xn, where n is the number of people that I'm sampling, or another word for n is the sample size. Well, we know that the people that we're sampling from, the distribution of salaries is normal distribution, this normal distribution here. So we know that the mean is 50, and there's actually quite a big variance. The standard deviation is 10, which is what you'd expect because the salaries are quite spread out in London. So you know that the majority of these people are going to be close to 50 in this distribution. But there's still a chance that I'm going to ask someone with a really high salary or a really low salary. So hopefully you understand that these x values are completely random, and which is why I've used a capital X, because they're random variables. Before I go out and actually do the experiment, before I go out and sample the people, I don't know whether I'm going to ask people with a high salary or a low salary. So what we're interested in is what's called the sample mean. So the sample mean is x bar. And again, I'm using a capital letter X here, capital X here, because X is random, X bar is random. And that's because on Monday, I might go out and ask people with, on average, quite a high salary. I might just be happening to ask lots of bankers, for example. And on Tuesday, I might go out and ask people with lower salaries. And when I work out X bar on Monday, the average on Monday, and when I work out the average on Tuesday, they're both going to be very different because I've asked different groups of people. So the sample mean is going to be random. So what we're interested in is how is this distributed, this sample mean, and can I try and predict what's the probability that x bar is within a certain region. So in order to help us think about this, we've got a simulation here. So I've set the sample size to 20, and thank you for this person for making this app for us to use. So I've selected a sample size of 20 here, which means on each day I'm going to go out and I'm going to ask 20 people what their salary is. And then I'm going to work out the mean of those 20 people. That's called the sample mean. And I'm going to place a pink dot on the place on the number line where that sample mean is. So for example, if you look at this pink dot all the way to the right, I asked lots of well-paid people, and on average, that sample, the sample mean was about 57, something like that. And on another day, if you look at this pink dot on the left, the average of the people that I asked on that day was much lower than that. Okay, so you can see that we've still got a spread. Let's run this simulation for a little bit longer and see what the distribution looks like. So this is what the distribution looked like when I ran the simulation for a bit longer. Remember, these blue dots on the top are what's called the underlying distribution that we're sampling from. So this is the values of x on this axis, and we know that x follows a normal distribution with mean 50 and standard deviation 10, so variance 10 squared. Now, this is the distribution of x bar because each of these dots represents what my sample mean was. And you can see that the vast majority of my sample means are centered around 50. And actually it turns out that the distribution of these sample means is normally distributed. So we could draw a normal distribution curve like that around our sample means. So this is the distribution of x bar now, and turns out that x bar has a distribution. The mean of the distribution, hopefully you can see that the both of these distributions are centered on 50. So the mean of the x bar distribution is 50. And that makes sense because if I go out and ask 20 people, on average, if I average out the days, I'm going to expect the sample mean to be the mean of the salaries in London, which is 50. Now the variance is different. Hopefully you can see that the variance of this sample distribution, this x bar distribution, is smaller than the variance of the x distribution, the distribution of salaries. And that's because the variance is actually 100 divided by the sample size, and the sample size is 20 because I was asking 20 people each day. And it's this divide by 20 part which means that the x bar distribution has a smaller variance. And the intuitive understanding for that is if I just went out and asked one person from this distribution what their salary was, there's a quite high chance that I ask one of these people in the right of the distribution, this person here, for example. Okay. Whereas if I go out and ask 20 people, it's really unlikely that all 20 of those people are going to be in the right of the distribution, which is why you don't really see any pink dots beyond about 57 here. It's just really, really unlikely that I choose lots of people. It's far more likely that I choose a spread of people within this distribution, and on average that sample mean, that x bar, is going to be closer to 50 when I work that out. So before we move on, you don't need to understand too much about the effect of sample size, but you might be interested to think about what would happen if you had a smaller sample size or a bigger sample size. Well, if we replace 20 with a smaller sample size, say a sample size of 5, then the variance would be a lot smaller. So actually, if we did that, our distribution might look something like this. And the effect of the smaller sample size is x bar is more spread out. And the reason why is because when you have a larger sample size, you're more consistent because you get a bigger spread with a larger sample size. For example, if I only ask these 5 people in this distribution, there's quite a high chance that I ask 5 people with these high salaries. Whereas if I'm asking 20 people, it's unlikely that all 20 of these people are going to be in the right of the tail. So before we have a look at the example and the topic of hypothesis testing, let's write down some general formulas. So if we have x, which follows a normal distribution with mean mu and variance sigma squared, and I have a sample of size n, so that means I go out and I collect n data points from this distribution, and if I work out the sample mean of these n data points, x bar, that's going to be a random variable, but I know that it's going to be normally distributed, and the mean of the normal distribution is going to be mu, and the variance is going to be sigma squared divided by n, where n is the size of the sample. So if we were to draw this out, if we put x bar on the horizontal axis, then this distribution, mu is in the middle, and sigma squared over n is going to determine the shape of this distribution, how spread out it is.